Hi everybody, this is Algebra 1, Lesson 71, and this lesson covers trinomials with common factors and subscripted variables. Alright, so first we're asked to factor this problem. When we look at this problem, we're looking for common factors before we try to factor it. And if we look at all these, common factors means factors that each one of these terms has. So this has x, this has an x, and this has an x. So what we do is before we factor it, we're going to pull out one x out of there. Okay? So if we pulled an x out of that, that would leave x squared. This would be 6 with one x left, and that would just be 5. Okay? Now we can factor it by drawing our parentheses. We got to see what we got in here. Let's see. X will be at the beginning. We need two numbers that multiply to make 5 and add to make 6, which will be 5 and 1. 5 times 1 is 5. 5 plus 1 is 6. And these will both be positive. So there's the answer to that one. So it's just like what we've been doing with factoring, but first you have to pull out your common factor. So in that case, it was the x right there. All right, let's try another one. Alright, this one, same thing. First thing we're going to do is look for common factors. So they all have a b. They all have an x. And then we need a common factor between 4, 4, and 80. And that will be 4. 4 will go into all of 3 of those numbers. Okay, so we're going to pull out 4b x. Now let's see what we have left. If we pulled out that 4, 4 times 1 is 4, so we just have a 1. We used up the b, we used one of those x's, so we'll have 2 x's left, so x squared. This one we would have negative sign, and we pulled out the 4, we pulled out the b, we're going to have 1 x left. Alright, how many times does 4 go into 80? That would be 20. We pulled out the b, and we pulled out the x. Alright, so there's that. Now we have to factor that down smaller. Okay, so both of these have x at the beginning. We need two numbers that multiply to make 20 and add to make negative 1. And that would be, let's see, 5 times 4 is 20. And if we made the 5 negative and the 4 positive, 5 times 4 makes 20. And then negative 5 plus positive 4 would be negative 1. So there's that one. Right, this one has a negative on our x squared. So the first thing we have to do for this one is multiply the whole thing times negative 1. So that will just change the signs in here. So we're just pulling this negative out. So it's going to change this sign to regular x squared. It'll change that to a negative. It'll change that one to a negative as well. So you have to change all the signs in here by multiplying the whole thing times negative 1 to get rid of this negative. Okay, now we can factor it further. We're going to have x at the beginning. And this is 5 and 4 again. 5 times 4 is 20, and then we have negative 1. So there's the answer to that one. So if you ever have a negative on your squared term, that one there, you have to multiply everything times negative 1 to change the signs to get rid of that negative. Okay, this one kind of combines that. So these all have, let's see, common factor between 3, 6, and 72. That'll be 3, and it's going to have to be negative 3 because we got to get rid of this negative. Alright, so at the beginning we'd be left with x. Oh, we can get rid of one of those x's too. Alright, negative 3x, and we would get rid of the negative 3, get rid of one of those x's, so we'd have x squared. How many times does negative 3 go into negative 6? That would be positive 2. 2 times 3 makes 6. And we have 1x left. And then how many 3's in 72? 24. Okay, and that would be negative 24. Negative 3. Nope, that would be positive. Yeah, it would be negative 24. Negative 3 times negative 24 makes negative 72. And we got rid of the x. Okay, so now we can factor this further. So we got negative 3x, and then we're going to write our parentheses, put our x's at the beginning, and we need numbers that multiply to make 24 and subtract to make 2, positive 2. So 6 times 4 makes 24, and if we make our negative on the 4 and our 6 positive, then we'll end up with positive 2. So there's the answer to that one. Okay, this next part is what's called subscripted variables. These look confusing at first, but they're really easy. This just means the number of nickels, and ND means the number of dimes. And it says that we're supposed to use elimination to solve this one. Okay, so that means we're going to add them together. All right, so I've got 5 times the number of nickels plus 10 times the number of dimes equals 125. And to use elimination, that means I'm going to have to change one of these. So I'm going to change that one, and I'm going to multiply that times negative 5. So then I'd have negative 5 times the number of nickels plus negative 5 times the number of dimes equals 16 times 5. 6 times 5 is 30. 5 times 1 is 5, 6, 7, 8, 80, negative 80. And then I'm going to put these together. So those cancel. And then I would get 10 minus 5 is 5 times the number of dimes equals 125 minus 80. 5 times zeros. 5 minus 0 is 5, 8, 9, 10, 11, 12, 4, 45. Then I'm going to divide by 5. And I get my number of dimes equals 9. So the number of dimes is 9. So now I need to find the number of nickels. So I could say my number of nickels plus my number of dimes, which is 9, equals 16. So now I just subtract 9, and I get my number of nickels equals 16 minus 9 is 7. Got 9 dimes and 7 nickels. Okay, so just like elimination that we've done before. This one we're supposed to use substitution to solve. Alright, so I have NQ equals, so all I'm going to do is substitute that into this when I get to NQ. So 5 times my number of nickels plus 25 times my number of quarters, and my number of quarters is number of nickels plus 2 equals 290. Okay, bring this down. 25 times my number of nickels, so I'd have 25 NN plus 25 times 2 would be 50. Okay, I'm going to add my like terms, so I have 30 times the number of nickels plus 50 equals 290. Now I'm going to subtract my 50. 30 times the number of nickels equals 240. Divide by 30. I think that's going to be 8. Three times 8 is 24. Yep. So my number of nickels equals 8. Now I need my number of dimes. I mean, not dimes, quarters. Let's see. So this says that I'm just going to sub it in this bottom one here. That looks like the easiest. So my number of quarters equals the number of nickels, which is 8 plus 2. So my number of quarters is going to be 10. Pretty easy, just like equations that we've been solving with the system of equations. substitution and elimination. Just your variables look more complicated, but really it's the same thing. Alright, go ahead and work those practice problems. Pause the video, work them out, and then I'll work them for you. Alright, so hopefully you pause the video and work these. This one asks you to factor. So first I got to find common factors and pull them out. I see they all have an x. And 4 will go into all those numbers. Negative 4 goes into all those numbers. Now let's see what's left. Took off the negative 4. I took off one of those x's, so I have x squared. Here I'm taking out the negative, so it'll be a positive. 6 times 4 is 24. 7 times 4 is 28. X, okay. 7 times 4 is 28, okay. And then this will be a positive 48. 4 times 12 is 48, and I got rid of the x. Alright, so now I need to factor this. Okay, I need a number that when we multiply we get 12, when we add we get 7. 6 times 2, no. 3 times 4. 3 and 4 is 7. So there's the answer to that one. Alright, this one we're going to have to pull out that negative. And it's not arranged in the right order. Alright, so first I'm going to put this in the right order. Now it makes more sense. We want descending order of the variables. We're going to have to pull this negative out. That's going to change all the signs in here. That one becomes positive, that becomes negative, and that becomes negative. Okay, now we're going to factor it further. Okay, so we're going to have an x on the beginning, and 6 times 4 makes 24. And we need it to be a negative 6 and a positive 4 because we want to be left with negative 2. And there's your answer. And there's two different ways. In the book, they don't write this 1 right here. They just have a negative in front of it. If it helps you, you can write the 1, but either way is correct. Alright, systems of equations here. We're supposed to use substitution for this one. So we're going to take this value and we're going to sub it in for number of quarters. So 60 times the number of nickels plus 24 times the number of quarters, and number of quarters value is number of nickels plus 5 equals 360. Bring this part down. Rainbow. 24 times 5 times 4 is 20, 5 times 2 is 10, 11, 12, 120 equals 360. Add like terms. Plus 120 equals 360. Get rid of this 120. 80 times our number of nickels equals 0. 6 minus 2 would be 4. 3 minus 1 would be 2. 240. Now we're going to divide by 80. The trick where you knock off your zeros. 3 times 8 is 24. So the number of nickels is 3. Oh, that should be quarters right there. Whoopsie. Oh, that's right. I did something wrong. Let's see. Three times 8 is 24. Okay, so now we need our number of quarters equals the number of nickels, which is 8, plus 5. And 8 and 5 would be 13. Yep, that's correct. there's that one. Pretty easy. This one we're supposed to use elimination. So that means that I'm going to have to multiply one of these. I'm going to multiply this one times negative 6. So I'm going to have 6 times my number of nickels plus 12 times my number of dimes equals 180. And then when I multiply this times 6, I'm going to say my number of nickels times negative 6. My number of dimes times negative 6. Oops. So that would be a negative. And then 6 times 12, which would be negative 72. Now I'm going to put these together. These cancel. And then we get 12 minus 6 will be 6 times the number of dimes equals, let's see, subtract 10, that'll be 8. 108 divided by 6. 6 times 8 is 48. 18. So our number of dimes is 18. Now we got to find our number of nickels. So our number of nickels plus our number of dimes, which is 18, equals 12. Subtract 18. Our number of nickels equals negative 6. So sometimes these can come out negative, and you might not have been expecting that, but it did. Alright, so there's the answer to that one. That's it for lesson 71. Thanks for watching.